Hello! Hopefully by the end of this video, we will be able to generate equivalent numerical expressions using order of operations. Let's dive in. Before we start going over or learning this concept, here is a catchy rap song over order of operations. I have used this as a resource in my classroom and it seemed to be successful. I will provide the link in the description box below. Just like the name of the concept, there is an order in solving the expression. An acronym PEMDAS will help us find the solution. Now I've learned it where M and D and A and S were separate, but with these operations, you do them in the same step from left to right. So I thought it would be helpful to write them side by side with an arrow below it to remind us to solve the expression going from left to right. For example, if division comes before multiplication in an expression, we must find the quotient first. Also next to MD, you see a triangle. This will help you when you multiply and divide integers because now that you're in middle school, negative numbers are introduced. If you cover or circle the signs of the two integers you are multiplying or dividing, the sign not covered or circled represents the product or quotient of the two integers. An example in utilizing this triangle is positive 3 times negative 2. The product in this example will be negative 6 because the other negative sign is not circled. Next, exponent is a new concept as well in middle school. I have found a video of a parody of All About the Base that seems to help my students understand the rule of exponents. I will provide the link below in the description box. I will quickly go over exponent. In this example, the exponent 2 tells you how many times you are going to write the base. Now with exponents, you are going to do the base times the base. In this case, we have our base 4 and we're multiplying it 2 times. So we have 4 times 4, which will give us a product of 16. You'll see parentheses around an integer. And that usually indicates that you are multiplying or separating an operation from a negative integer. So for example, 4 parentheses 2. That indicates that we are going to multiply 4 and 2. Now the other example I said is that it's going to separate an operation from that negative integer. So for example, 5 plus negative 3. You see that parentheses is used so that you won't get confused with the plus sign and the negative integer. In this case, it's a negative 3. Now, other times you'll see parentheses in the use of grouping number and operations together, in which case then you will tackle the first step of parentheses in order of operation. At the end of solving the expression, you should see a triangle with the vertex pointed below, or as my students like to say, a Dorito chip or an upside down Christmas tree. In our first example, we have the expression 4 times 5 plus 2 times negative 8 minus 12 times 3. If you want to give it a try, you can pause the video and solve it yourself. In order to solve the expression, we need to perform the order of operation. Let's first write down our acronym, PEMDAS. Underneath multiplication and division, don't forget to draw an arrow. That tells us that we need to go from left to right, as well as for addition and subtraction. Now next to M and D, we need to also draw our triangle. This helps us know whether our product or our quotient is going to be a positive or a negative integer. Now the first step is we need to check if we have parentheses. Here, if we look at the expression, we do have parentheses, but these parentheses are used to multiply the two integers. And the P, or parentheses, in PEMDAS, it represents a group of integer and operations together, which we don't have. So now let's move on to E, exponents. Exponents, we also don't have that, so let's move on to multiplication and division. Now here we see that we have three multiplications, 4 times 5, 2 times -8, and 12 times 3. Now don't forget, we need to go from left to right. So let's first do 4 times 5. 4 times 5 will give us a product of 20. Now we need to bring everything down, plus 2 times -8 minus 12 times 3. We're not done with the step, so let's do the next multiplication, 2 times -8. Now let's go to the triangle. We have a positive integer of 2, and we have a negative integer of 8. If we multiply the two, we have our product, -16. After we're done with that, don't forget we got to bring everything down. 20 plus -16 minus 12 times 3. Let's do our last multiplication. 12 times 3 gives us 36. Then bring everything down. 20 plus -16 minus 36. Now we need to add and subtract. We have to also do it from left to right. So first we have to add 20 and -16. Remember, we have two different signs of integers. We have a positive 20 and a -16. So since they're different, we need to subtract 20 minus 16. We need to borrow from the 2 and regroup our ones. 10 minus 6 is 4. 1 minus 1 is 0. So our sum is 4. Now, we have more positives than we have negatives. We have 4 more positives than we have negatives. So we have an integer of positive 4 minus, and then let's bring down our minus, 36. Now we have to do our final step, 4 minus 36. Let's do that off to the side. When you subtract integer, our rule is to do K, C, C. Keep change, change. You may draw the line to separate the integer and the operation. So we need to keep our 4. We need to change our minus to an addition sign. And we have to change our positive 36 to a negative 36. Now just like the step before, we have two different integers, so we need to subtract. 36 minus 4 is 32. And we need to ask ourselves, do we have more negatives or more positives? In this case, we have more negatives. So that means our difference is negative 32. Now, if you look at this, as you solve the expression, you're going to end up with an upside down triangle, like I've mentioned before. Or you could think of it as a Dorito chip. In the second example, our expression is the sum of two groups. First group being 4 times negative 6 plus 9. Second group is negative 32 divided by 4 times negative 3. Now, like the first example, let's write our acronym PEMDAS with our arrows underneath representing that we'll go from left to right, and our triangle next to MD. Now, since we have two groups of parentheses, let's tackle them from left to right. We don't have another set of parentheses within this group, and we don't have exponents, but we have two operations going on. We have multiplication and we have addition. Now we know that multiplication comes before addition, so let's find the product first. Let's use our triangle. Positive 4 times a negative 6 will give us a product to be a negative 24. And let's bring everything down. Plus 9, and make sure you include the parentheses as well. Plus the second group, negative 32 divided by 4 times negative 3. Let's first finish the first group, negative 24 plus 9. So since we have two different signs of integer, let's subtract 24 minus 9. Borrow from the 2 and regroup. So we have 14 minus 9, which will give us 5. 1, bring the 1 down. Now you might be asking, why are we subtracting? So if we just draw a quick little number line right here, we start at negative 24 and we add 9. So since we're adding, we're going to move 9 spaces to the right, which will be a greater number than negative 24, which is negative 15. And then bring everything down, plus negative 32 divided by 4 times negative 3. Let's tackle the second group. Here we have two operations as well. We have division and we have multiplication. Now since we have M and D in the same step, make sure we do it from left to right. In this case, we'll be dividing first. Negative 32 divided by 4. Let's utilize our triangle. We have a negative integer divided by a positive integer, so our quotient will be a negative. Negative 32 divided by 4 will be negative 8. And let's bring everything down. Now let's finish our second group. Negative 8 times negative 3. Let's utilize the triangle. Negative times a negative is a positive. So we have our product to be a positive 24, and bring everything down. Negative 15 plus 24. Now, like the other example up here, we're adding integers. So since we're adding two integers with different signs, we're actually going to be subtracting them. If you look at this example, there actually is a relationship between the two. Fact families, right? So we can assume that the difference will be 9, but just to check our work, we can't do 4 minus 5, so let's borrow and regroup. 14 minus 5 does give us 9. 1 minus 1 is 0. So we have 9. Now we have more positives than we have negatives, so it will be a positive 9. That is our answer. Just like the other example, make sure you end up with an upside down triangle. Now to our last example. We have 9 groups of 20 plus 2 to the 4th power divided by 2 times negative 4, all subtracted by 20. Let's first write our acronym, PEMDAS. Don't forget our arrows and our triangle next to multiplication and division. Now we do have parentheses, and within the parentheses, we do not have another parentheses, but we do have exponents. 2 to the 4th power. Remember that exponent 4 tells us how many times we're going to write our base 2. And when we're dealing with exponents, remember we're multiplying the base. Two to the 4th power equals 2 times 2 times 2 times 2. 2 times 2 is 4 times 2 times 2. 4 times 2 is 8 times 2 is 16. So 2 to the 4th power is 16. And make sure you bring everything down. 9 parentheses 20 plus 16 divided by 2 times negative 4 minus 20. Now we still have parentheses. So after exponents is multiplication and division. We do have division and multiplication. And in this problem, division comes first. So let's do 16 divided by 2. They're both positive. So our quotient will also be positive. Positive 8. And let's bring everything down. Plus, don't forget the plus sign. Now, a lot of students accidentally write divided by 2 again. That's why I underline what we're solving the step before. So that way I don't write it again. So let's bring down times negative 4 minus 20. Remember, we have multiplication left to right, and positive 8 times a negative 4 gives us a negative product. 8 times negative 4 is negative 32, and let's bring everything down. 9 groups of 20 plus negative 32, all subtracted by 20. Now we're adding integers, so that means we need to subtract since they are two different signs, one positive, one negative. So let's do 32 minus 20, which will be 12. Now if you look here, we have more negatives than we have positives. So our sum is actually a negative 12. 20 plus negative 32 is negative 12. And bring everything down just the way it is. Now we're done with the parentheses. So if we were to read it from left to right, we have 9 times negative 12 minus 20. So we have multiplication first. So let's do 9 times negative 12. Remember, positive times a negative will give us a negative product. 12 times 9 is 108. And bring down minus 20. Now let's write that off to the side. Negative 108 minus subtracting 20. Now when we're subtracting, make sure you do KCC, keep, change, change. Keep, change, change. And you can draw your line to separate the operation and the integers. So let's keep our negative 108, so bring it down. We're changing our subtraction sign to an addition sign, and we're changing our positive 20 to a negative 20. Now, we're adding integers, and we have two negative numbers. They're both the same sign, so that means we're actually going to be adding them. Because you start with a negative number, so if I were to draw a number line, we start at a negative number to the left, negative 108, right? And we add more negative. So since we add more negative, we move more to the left side. And we add negative 20. So 108 plus 20 gives us 128. Now since they're same sign, we have to keep the sign. Same sign, keep the sign. Okay. And so our difference is actually negative 128. Make sure at the end, you know you're doing it right when you end up with an upside down Christmas tree. Thank you for watching this video over order of operation. I hope this video helped you understand this topic better. If you have any questions, please message me. Bye!